Hi, I'm David. I'm going to try to go over this recursive problem and try to make more sense of it. And this is function notation for a recursive problem. So let's first just dive into how to answer this question. The first thing it says is a of 1. So the plug value of 1. In other words, it looks like we're using n. So when n is 1, in terms of sequences, that's the first term they're referring to. And it says right here that it's 7. So we just want to put a 7 in for the first term. The main part of this lesson is trying to read this notation right here. And all it is function notation, but with the n minus 1, I'm hoping that eventually you start to see that as previous term. There's been lots of conversations in our class about previous terms and next terms, or previous step and next step, and this is along that idea. So we want to look at this as previous term down the road. But right now, I just want to plug in a value and methodically work it out to see what it says, and then maybe build the understanding of previous term after. So if I want to get a of 2, second term, a of 2, second term, then the n value there is 2. In other words, the second step, the second term of this. So I'm going to follow the rule on the other side. Remember, functions at the heart are rules, a set of instructions. I'm going to plug in n is 2. Wherever I see n, I'm going to plug in a 2. So it said n minus 1. I'm going to put 2 minus 1. And then I'm just going to rewrite the rest of the equation like we normally do in mathematics. Let's just clean this up a little bit because I know what 2 minus 1 is. So I'm going to write a of 1, or what is the answer for the previous term, a sub 1. And then I'm going to take that value and I'm going to subtract 3. Since it has been established that a of 1 is 7, this now looks like 7 minus 3, or 4. And that is the next term. You can again follow the plug and chug, do a of 3 and kind of jump the gun and say, well, it's going to be the previous term that I just got, a of 2, and I'm going to minus 3, so that's going to be a 4 minus 3. You can plug and chug it, you can keep plugging and chugging, or you can recognize that this rule now is subtracting 3. And when you look back at the function's name, a of n equals a of n minus 1 minus 3, that is just a bunch of math symbols that simply say, take 3 away from the previous term. The hard part about this problem right here is making sure you don't accidentally do some really good math, because your brain probably is saying something like distribute when you see that. And I want to respect that. I think that's, like, what I call an awesome perspective, or in this case, a mistake. But this is a mistake we want to grow from. Now that we got to feel that this is an object, c of n minus 1, remember this is the previous term, then what I want to do is I don't want to look at it as something to distribute to. Right now I'm looking at it as if it's an object, something with an answer, a numerical answer. So that's the way I want to view it. Again, we can just plug in c of 2. C of 2, again, this is n is 2, and I'm just going to follow the rule. It says to multiply 10 times c of, and remember n's 2, so 2 minus 1 again, 2 minus 1 again. That's the whole equation. It looks like I'm done there. C of 2 minus 1, well, that's 10 times c of 1, because 2 minus 1 is 1. And it says right over here on the right that the first term, that I could probably put in, is 3. C of 1 is 3, is now going to be hopefully translating in your head to be, well, the first term. Okay, that is assuming we're starting on step 1. Sometimes they start on step 0, but just be flexible there. So it looks like 3 is the first term. So now this equation says 10 times 3. 10 times 3. 30. Now we're going to try to get the next one. Again, you can just plug in, use function notation, maybe jump the gun a little bit. I'm going to use parentheses this time instead of the dot. So now I'm going to multiply to the object, to the output of the function, where C of, and we want to do 3 minus 1, right? 3 minus 1 based on that little, based on the rule. So it's C of 2. So that basically means 10 times C of 2. 10 times C of 2. C of 2 is just been found to be 30. So now this is 10 times 30. You could also start to recognize that the rule seems to be multiplying by 10 to the previous term. I'm David. I hope that helps.